This is video number 3 for sections 2.1 and 2.2 on equations of linear models. As it says here toward the top, linear models become much more useful when we find their equations. In the last problem, we focused on the graph of the linear model, and that's fine, but it's going to be a lot easier for us to complete the work in these problems if we can just find the equation of the model. Here's the scenario this time, a baseball problem. The number of kids participating in Little League has decreased approximately linearly from 2.6 million in 1997 to 2.1 million in 2011, according to the Little League International. Well, if we want to follow our typical progression here, we're going to need to define a couple of variables, and that's actually been done for us. This next statement tells us that N is going to stand for the number of Little League participants in millions, and T is going to stand for the number of years since 1990. As usual, we need to begin by identifying which is our independent variable and which is our dependent variable. And we've said already that they're always in these problems telling you the dependent variable first. So N will be our dependent variable, and T will be our independent variable. This simply means that the number of kids participating depends on what year we're talking about. All right, the next step normally would be to draw a scattergram to take our data and draw a graph. Letter B says 2 data points are really not enough. They only gave us 2 data points in the original paragraph. There's no point in drawing a picture. I can't see a pattern if I only have 2 points. However, it goes on to say, I don't need to draw a picture. I already know that this data follows a linear pattern. Well, how could I possibly know that? Well, the simple answer is that they told us. Back up in the original problem, they already indicated to us that this data follows a linear pattern. The idea is that someone already took the full set of data and made a scattergram and realized that the data followed a linear pattern, and they're just providing for us a brief summary in this paragraph with a couple of data points. We already are going into this knowing that the data follows a linear pattern. All right, well, we've got 2 data points. Remember that there are times where we have to adjust the data to match the definitions of the variables. Let's take a look here. T, we said, stands for the number of years since 1990. So I don't want to write 1,997 in this box. I need to be writing how many years it's been since 1990. Well, 1997 would be 7 years later. Similarly, the other data point, 2011, that would be 21 years after 1990. The N values in this problem, well, let's go back to the definition. N stands for the number of participants in millions. So when they say that in 1997 there were 2.6 million kids involved, I'm not going to write a 2, a 6, and a whole bunch of zeros after that. The N number represents millions. So I'm simply going to fill in 2.6. That doesn't mean 2.6 kids, that means 2.6 million kids. And similarly for 2011, the number dropped to 2.1. Now that we have our adjusted data points, we can go down to letter D, which says we're going to use those 2 data points in order to find the equation of the linear model. This is really just the same work that we learned how to do in chapter 1. Now maybe it would be beneficial as we start here to write those 2 data points as ordered pairs. So we have 7, 2.6 and 21, 2.1. How do we write an equation? Well, the first step is to figure out the slope. So I use my slope formula, y2 minus y1 over x2 minus x1. That gives me 2.1 minus 2.6. over 21 minus 7. The top comes out to be negative 0.5, and the bottom comes out to be 14. Then I would grab the calculator and type negative 0.5 divided by 14, which gives me approximately negative 0.036. I noticed up in the directions it says that I'm to round all final decimal values. The slope would be a final decimal value to 3 decimal places. Now I have a choice going forward. I can either use the y equals mx plus b method to find the equation of the line, or I can use the point slope formula to find the equation of the line. I think the point slope formula will work nicely here, so I think I'll use that. Let's jot that formula down. The formula is y minus y1 equals m parentheses x minus x1. Remember, x and y are the final x and y that show up in the equation. All I need to do is fill in the slope number as well as the coordinates of a specific point, and I'll just go ahead and use this first point. So let's fill that information in. So I have y minus 2.6, 2.6 was my y coordinate, equals negative 0.036, the slope, parentheses, x minus 7, 7 being my x coordinate. Looks like the next step is to go ahead and distribute here on the right. So that gives me y minus 2.6 equals negative 0.036x plus 0.252 using the calculator. All right, we're almost there. We just need to get that y by itself, and I can accomplish that by adding 2.6 to both sides. So let's do that. And then one more time on the calculator, and we ought to have what we need. And so that gives me y equals negative 0.036x plus 2.852. Now you may have noticed in the original instructions, it says you can carry out your work with x and y, which I think is a good idea. That's just what we often use. But be sure to put in the correct variables at the end. We have to remember there is no x and y in this problem. We had t for our x and n for our y. Well, we just need to substitute that in here at the end. And so this gives us a final equation, n equals negative 0.036t plus 2.852. Once you have the equation of the linear model, there's all sorts of things you can do. You can answer many, many different types of questions. Just as an example, to wrap this problem up, letter E says, well, now that we have the equation, what if we wanted to predict the number of Little League participants this year? Now, we don't necessarily have to work all that out, but let's think about how we would do that. This video is being recorded in the year 2017. Well, I don't have a place to stick the actual year in the equation, right? I have to think about my variable definitions. T, going back to the beginning of the problem, remember, stood for the number of years since 1990. Well, for me, 2017 would be 27 years since 2090. So I would just need to go to my equation and plug in 27 in place of t. Grab the calculator, do a little bit of work, and you would be able to answer the question. Keep in mind, of course, that the n value you end up with is in millions. And so, for example, if you were to end up with 1.9 for n, that would mean 1.9 million kids participating in Little League this year.